Hello. In this video, we're going to go through how to convert this number, which is in base 2, and I know that based on the subscript 2, into base 16. We're going to do this two ways. We're going to go through a longer version, which is converting from base 2 to base 10, and then into base 16. And then I'm going to show you a shortcut to go directly from base 2 to base 16. This shortcut is really useful if you work with computers because we often talk in base 2 or base 16. Okay, so the first thing I've done over here, you notice, is I've written out all my powers of 2. And that's because we're working in base 2. Each placeholder represents a power of 2. So this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. And you can see I've written these all down here. So this works in the same way that if you had, for example, let's say 321 in base 10. Well, 321 in base 10 is like saying 1 times 10 to the 0 plus 2 times 10 to the 1 plus 3 times 10 to the 2. So that's how we work in base 10, and we do that without thinking. And it's the same principle in any base. So therefore, here, if I take a look at this, I start at right here on the right-hand side, and I see I have 0 in the 2 to the 0 spot, 1 in the 2 to the 1 spot, 0 in the 2 to the 2, 1, 1, and we can just keep working across here, 0, 1, 0, 1, 2, 3, 4, 5, 6, and I think it's 6, 1, so 1, 2, 3, 4, 5, 6. And we don't have a 2 to the 14 or 2 to the 15, so I just put 0 in there. So there is my binary number written out, and it's associated with the placeholder. So that means we have 0 2 to the zeros. We have 1 2 to the 1, which is like saying 1 times 2. We have 0 2 to the 2's, which is like saying 0 times 4. And we simplify this, so we have 1 times 8, which is 8. 1 times 16, which is equal to 16. 0 times 32, which is 0. So what I'm going to do is I'm going to work all these out, then add them up. So if we take a look on this side, we see we're going to add 2 plus 8 plus 16 plus 64 plus 256 plus 512 plus 1024 plus 2048 plus 4096 plus 8192. And so now these are all in base 10. I know they're in base 10 because I don't have a little subscript. I could put a 2 sub 10, but because we work in base 10 so much, we just typically don't write one. Plus 8 plus 16 plus 64 plus 256 plus 512 plus 1024 plus 2048 plus 4096 plus 8192, and we get 16,218. And so that is my value. 16,218. That's my value in base 10. So now that I have this number in base 10, and I could put a sub 10 there if I wanted, I'm going to convert it to base 16. So a nice little thing to point out is that if you're using Windows, and I'm sure Mac has a similar thing, your calculator has a programmer mode. And so I can actually select the base that I want to use. So if I'm in binary, I'm going to type this in from left to right. So 1, 2, 3, 4, 5, 6, 0, 1, 0, 1, 1, 0, 1, 0. So there's my number, and we can confirm it along here. And if it's in binary, all I have to do is select the other base, and it converts it for me. And I see that that number in base 10 is 16,218. And I can have the calculator actually convert it into hexadecimal for me. So I end up with 3F5A. Now, that being said, we want to be able to do this manually. So now we're going to go from 16,000, let's see how we do that, 218, and we're going to convert this to base 16 or hexadecimal. So what I do is I actually take this number and it's just a process I go through. I'm going to take 16,218 and I'm going to keep dividing by 16, and all I'm really interested in is, well, I'm interested in both the remainder and the quotient. So let's divide this by 16. And if I divide this by 16, what I see is I get 1,113, and my remainder is 10. Okay, so then what I do is I take 1,013 and I divide that by 16. So let's just, I have my calculator here next to me. And I see that I get 63. And my remainder is 5. So now I take 63 and I divide that by 16. So 63 divided by 16, and I get 3 with a remainder of, let me just try this once more. I get 15, remainder 15. So then I do 15. Oh, sorry, not 15, pardon me. I'm going to do 3 divided by 16. And I see this equals 0, remainder 3. So when I go through this process, and just so we're clear, this works for any base. I could be working in base 5, base 20. I just keep dividing by the base. And what I'm doing is I'm calculating this value, and then I'm redividing it. Finding this value, redividing it. Finding this value, redividing it. And when I get 0, this is when I know I need to stop. And what I'm interested in is it's the remainders that make up the number. These make my number. So therefore, I have 10, 5, 15, 3. But remember, hexadecimal, so hexadecimal, hex has has 16 values that can go on a placeholder per placeholder. So they have our standard 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but they also have 10, 11, 12, 13, 14, 15. So we actually represent 10 by A, and then we just C, D, E, F. So this is 10, 11, 12, 13, 14, 15. So therefore, if we take this now, and we're going to go from left to right. So therefore, 16. Therefore, we can actually write this as the number is 3, and then I have 15. So 15 is F, 5, and then I have 10, and 10 is A, and that is my number in hexadecimal. Okay, so that's great, but it takes a long time. But it's really important you understand the process of doing that, because that means you can do it with any number. But let's look at a neat little trick here. What I'm going to do is I'm going to start by taking this number, and let's copy this. Let's come down here a bit, and let's paste this. So I'm going to show you a really neat trick here. So what I'm going to do is I'm going to count in 4s. Notice that 2 to the power of 4 is equal to 16. So therefore what I do is I'm going to underline groups of 4. So there's 4, there's 4, there's 4, and at the end I have 2, but what I'm going to do is I'll just add 2 more zeros on the end to complete this. So all I do now is I convert each of these. So I can convert these binaries in my head pretty easily. So 0, 1, 0, 1 in base 10 is 10, and in base 16 that's A. So this is 2 to the 0, which is 1, plus 2 to the 2, which is 4. That gives me 5. So therefore in hexadecimal that's 5. We have 1, 1, 1, 1. So this is going to give me in binary 15. And hexadecimal that's F. And we have 1, 1, 0, 0. And that in base 10 is going to give me 3, which is in hexadecimal 3. So therefore, convert this really quickly, we see we have 3F5A. And that's a shortcut to going from base 2 to base 16. I hope this video helped.